ABB Business Unit Marine and Cranes has developed a revolutionary system philosophy for power distribution. It involves using direct current as the main energy carrier between generators and large consumers. This eliminates main switchboards and drive transformers. We call it the onboard DC grid. ABB's first delivery of the onboard DC system was to the 93-metre-long, 5,000-tonne Dina Star, a multi-purpose offshore supply and construction vessel operated by Mikler-Bøsberg Management. The onboard DC grid has been through rigorous full-scale tests in Turkey, Switzerland.
I would say that the tests have been very successful. We saw a few challenges before we started. Those challenges we were able to meet very successfully, and the last weeks of tests and demonstrations have shown that we are able to do this consistently and well.
The safety protection was a challenge. The break of DC current compared to AC current is totally different. If we couldn't manage a safety system, we wouldn't have the onboard DC grid. So safety comes first at sea.
A backbone of bus ducts enables the transmission of power between larger components of the DC grid system. These bus ducts are epoxy cast groups of copper or aluminium bus bars. The new onboard DC grid system takes up less space than the old AC system and allows more flexible placement of components throughout the vessel. This frees up much needed space for more important functions, like extra cargo tanks. The team behind ABB's DC grid expects the initial operational experience to verify fuel savings estimates for Dina Star.
We hope to verify our assumptions for reduced emissions and reduced fuel consumptions, and we will measure reduced fuel consumptions through our advisory system, EMMA.
One of the biggest benefits for this system, as we see it, and following the owner and the yard, is that the main engines can work on variable speed depending on required load.
Onboard DC grid allows diesel engines to run at variable speed for optimal fuel consumption. This curve shows fuel savings for a typical medium-speed engine run at variable speed compared with constant speed. Depending on the vessel's operation profile, the efficiency gained will be from 5% to 15%. ABB believes that onboard DC grid will be a trendsetter for propulsion and power systems for many types of vessels in the near future. With the onboard DC grid, a wide range of vessels with low-voltage power systems, such as offshore support vessels, ferries and yachts, can reduce their fuel consumption and emissions by up to 20%. For the ship owner, this will mean a more flexible and competitive vessel.
On the sea trial, the noise and vibration level on board was very, very low. The generator running on 1400 RPM at 12 knots. So it's looking very good, but we need more experience. Looking forward to test out the vessel.
The feedback that we've had from our customers, the owner, shipyard and so on have all been one of amazement, that a system that's so young is so functional and so safe. So I'm a happy man.
To the ship owner, onboard DC grid means increased space for payload, less maintenance of generator sets, improved dynamic response and maneuverability, being ready for new energy sources, and up to 20% fuel savings. Onboard DC grid, a significant step forward in electric propulsion.